And once again, we are back with gas laws. This one, yet again, is not labeled. So we're going to determine which gas law we are going to be working with by first taking and making our shopping list so we see what variables there are. And then we're going to see what light bulb moment might occur for us while we're working this out. So let's read the question. Determine the new temperature in degrees Celsius for a sample of neon with an initial volume of 2.5 liters at 15 degrees centigrade. When the volume is changed to 5 liters, pressure is held constant. So let's go ahead and take a look at what variables we have. So it says determine the new temperature. So apparently we're going to have an old temperature and a new temperature. Okay? And it says determine the new. So this is the one I don't know. And they want it in degrees Celsius. Okay? A sample has an initial volume. So that's going to be at the beginning. So that's going to be a V1. So if I have a V1, I'm going to have a V2. So we have an initial volume of 2.5 liters at 15 degrees centigrade. When the volume is changed to 5 liters. Yet again, we are given 3 of the 4 variables that we're actually needing to work with here. So we need to take a look and see what they gave us. So we need to know what formula. Well, let's talk about it. We get patients ready. We're nursing students. We have to get patients ready for CT scans. Uh-oh. Erica must be giving me a light bulb moment. Okay. I give 2 scenarios for this. Nursing students get our patients ready for CTs. So we know T is temperature. And who's going to give me a temperature? Who's going to take my temperature? It's going to be Charles. Okay? One thing I also like to kind of give people to kind of make them laugh, give them a chuckle, because if you laugh, you'll remember it. Charles gives us the T. Okay? Charles always gives us the T. Okay? So let's take a look. What is our initial, without being changed, formula for Charles' law? So we're going to have a V1 over T1 equals V2 over T2. But don't plug any numbers into this. That means I've got to move a whole lot of numbers and units. Let's move it before this, okay? So if we're going to need to determine the temperature, in the end, I'm solving for T2. Okay? I'm solving for T2. So I'm going to go from a T all the way over to another T. So I'm going to go T to T. It has moved from the bottom, now it's up top. And that volume of V1 has also moved to the bottom there. So we're now solving for T2. So don't reinvent the wheel. You've been given the formula sheet. Utilize it because it gives it to you already conjugated or the derivative. So now all you need to do is plug in the information that you have. So let's start plugging in what we're given. We have T2 equals V2. So what's my V2? I have 5 liters. T1. Uh-oh. We're dealing with gas laws. What's another light bulb moment with gas laws? We must always convert our temperature to Kelvin. It must always be converted to Kelvin. So in order to do that, whatever your Celsius is, it's going to be centigrade plus 273.15. So let's apply that to this temperature here. We're going to add 15 plus 273.15. This is now going to be Kelvin is the standard unit of temperature for gas laws. Okay? So we're going to make sure that we change anything that's centigrade into Kelvin prior to working the problem out, or at least catch it during the working out of the problem. So now we'll multiply that by 288.15 Kelvin divided by our first volume, which is 2.5 liters. Once again, we're going to cross out our like terms. So liters and liters is left, and we're actually solving for a temperature. Kelvin is a unit of temperature, so we know we are going in the right direction. Now let's use our calculator and multiply the numerator here. So 5 times 288.15 gives us 1,440.75. And then we're going to divide that by 2.5. Okay? Once we do that, once again in our calculator, it gives us 573.3 Kelvin. But if we remember, our question asks us for the temperature in degrees Celsius. So we would need to take this Kelvin and convert it back to Celsius. So to do that, we would take our Kelvin temperature and subtract the 273.15, leaving us, 276. Which then leaves us with 303.15 degrees Celsius. And that would be our final answer for this Charles Law question.